Mechanical steam traps operate in response to the difference in density between steam and condensate. One common type of mechanical steam trap is an inverted bucket, or IB trap. The trap is named for the open float that's contained in the trap's cylindrical casing. The float is a bucket-shaped device that's been inverted or turned upside down. The top of the inverted bucket has a small hole or vent that allows air and non-condensable gases to leave the bucket and collect in this part of the casing, which is sometimes called the cap. The top of the inverted bucket also has a clip that's attached to a connecting rod. The rod connects the bucket to the trap valve. During proper operation of the trap, the casing is filled with condensate to a level that's just above the top of the bucket. This level of condensate is called the prime. The prime provides a water seal that prevents live steam from escaping the trap under the bucket. At startup, the bucket, which we've cut away, rests at the bottom of the casing, and the trap valve is fully open. Condensate from the steam system drains into the trap and flows under the bottom of the inverted bucket. The condensate passes between the outside of the bucket and the inside wall of the casing. The small vent in the top of the inverted bucket allows condensate to collect in the trap without lifting the bucket. As long as the trap is full of condensate, the bucket remains at the bottom of the casing, and the trap valve stays open. The condensate flows through the valve to the trap outlet. When steam enters and accumulates to fill about 2/3 of the bucket floats and the trap valve closes, so no more condensate discharges. While the valve remains closed, air and non-condensable gases, which are less dense than the condensate, pass through the bucket's vent and collect in the cap area of the casing. Meanwhile, more condensate enters the bucket, and some of the steam in the bucket condenses. When only about 1/3 of the volume of the bucket is filled with steam, the bucket drops, and the trap valve opens. Accumulated air is discharged first, then condensate. The flow of condensate under the bottom of the bucket picks up dirt and sweeps it out of the trap. Condensate continues to discharge until more steam floats the bucket and the cycle repeats. Because an inverted bucket trap works on a cycle, the trap has an intermittent discharge. Accumulated steam closes the trap valve, so there's no discharge from the trap, although condensate continues to drain into it. Accumulated condensate opens the valve so that the condensate can be discharged from the trap. The open float in an inverted bucket trap makes the trap resistant to water hammer. Inverted bucket traps are also able to handle air and other non-condensable gases because these gases are less dense than condensate. However, the vent in the top of the bucket is small, and only a correspondingly small amount of air can pass through it. So to avoid problems, inverted bucket traps generally should not be used if large volumes of air must be removed. A leaking trap valve is a common problem that can cause an inverted bucket trap to fail. The leak is often the result of damage or wear on the valve or the valve seat. If the valve doesn't seat properly, it will leak, and the trap may fail open, that is, with the trap valve in the open position. The trap will also fail open if the bucket becomes disconnected from the rod that connects it to the trap valve. Also, freezing and the damage it causes can be a problem with an inverted bucket trap, because normally the trap always contains some condensate. To prevent freezing, inverted bucket traps that will be shut down for a significant length of time should be drained.